Howdy, my name is Carlos Daniel, and today I'm making this video on Chem 120. I'm doing it on the comprehensive assignment number one. So today I will be solving problems related to saline solutions. This will be dealing with enthalpy, entropy, and colligative properties. So let's get started. All right, so for number one, it's asking describe the enthalpy changes when dissolving sodium chloride in water and explain when they mix. So there are two main processes that happen. One is the breaking of ionic bonds in the sodium chloride. So this is an endothermic process, meaning it absorbs energy, making enthalpy more than zero, making it positive. Um, And then the second one is hydration of ions by water molecules. So this is an exothermic process, meaning it's releasing energy. Moving on to question two, it asks, how will entropy change in making saline solutions? So the entropy, which equals S, um, it is given that energy increases due to the breaking of ions in water on the system. The entropy increases, then slightly decreases due to hydration. So the entropy will overall be positive. All right, so moving on to question three, it reads the 0.9% of sodium chloride solution has a density of 0.104 grams per milliliter, right? So it's asking us to calculate the following. So for A, it's asking us calculate molality. So as we know, molality equals moles of solution over the kilograms of the solution. So moles of the solute over kilograms of the solution. So the way we get the moles of the solute, we would have to use the given, which is 0.9%. Um, and it doesn't tell us like the exact weight of the solution. So let's just assume 100 grams just to make it easier. So assuming 100 grams, we would have zero point 0.9 grams of sodium chloride. So we would then multiply that by 1 mole of sodium chloride over its molar mass, right? So then that would equal our moles for the sodium chloride in the solution, which is 0.0154 mole. Um, After that, we would just get the weight of the solution, which is one. I subtracted here, but this is kind of wrong. So the full weight of the solution in kilograms is zero point 0.1, and that would give us 0.54, 0.55, right? So we would have 0.55. All right, moving on. Moving on, we would have. It would give us 0.44. Sorry about that. Moving on, it wants us to look for the mole fraction. So as we know, the mole fraction of sodium chloride, it equals to the moles of sodium chloride over the moles of sodium chloride plus the moles of water. So that would equal to the mole, which we already have, plus the mole of water. The mole which we already have over the mole of sodium chloride plus the mole of water. So we would just have to find the mole of water, which is 5.5 mole, and this equation, which would be the mole of sodium chloride over the mole of sodium chloride plus the mole of water, it would equal 0.00279 mole. And that's the mole fraction for sodium chloride. Then we would have to find the molarity. Finding the molarity, so molarity equals moles of solute over the volume of solution in liters. So as we know, the volume of water translates, it's like 1 to 1 with its weight. So that would then be 1. So that would then be 1. So it'd be the mole of sodium chloride over over the weight of the solution, which is zero point 0.1. 0.1. So that would equal to um, 0.155 molarity. Then we would have to find the parts per million. So this was fairly simple. So we would just have to get the grams of the solute over the grams of the solution. So it's kind of, yeah, no, it's kind of like what we did right now. And kind of. So it would just be the grams of the solute, which is zero point 0.9 grams, which is the given, over the 100 grams of the solution, and times 10 to the sixth power. And then we would do that same first process, and instead of times 10 to the sixth power, we would do times 10 to the ninth power, and we would get our part per billion. So here we have our part per million and part per billion. Moving on to the vapor pressure, we would have to use Raoult's law. Starting this equation, we'd have to get the vapor pressure, or yeah, we would have to get the vapor pressure of the solution, and then we would get the mole fraction of water, which we found here. We should have found it in the last one too. And then we get the vapor pressure of water. So it already gave us right now for question 4. I forgot to read it, but right here it gives us the vapor pressure of pure water, and that is 92.665 torr times the mole fraction of water, and that would equal to 92.39 torr, and that's the vapor pressure of the solution. So moving on, we would get to the boiling point of elevation, and the equation for that. All right, yeah. So moving on to 5 again. Sorry for that cut. We're looking for the boiling point elevation. So the the equation for that would be delta TB equals the boiling point elevation constant, which is actually a given here, times the molality of the solution. So we would just multiply that, and we would get the delta TB. And then after that, we would use that to get the full boiling point. We would use that with 100 Celsius plus what we got, and that would equal the boiling point of the solution. So then the freezing point, which is number 6, it is fairly similar. So it is delta TF, or yeah, delta TF equals the freezing point elevation constant, which again, it's a given. So it's 1.8 times the molality. And then our product from here, we would just subtract that from 0, and then we would get the freezing point. So yeah, that is basically all of this. Thank you, and gig 'em.